Try to pay attention. It's going to be very interesting. And um, yeah, let's see.
Yeah, recording is on. Okay.
Okay. Okay. So what did we discuss?
The SNP introduction. Yeah.
Yes, yes, yes. So we got to continue on that and see a lot of scenarios, and there will be hundreds of scenarios, which obviously we cannot cover because every business works in a different way, and then they have multiple requirements. But yeah, 19th we connected, and then started with the supply planning. I would say initial master data setup and initial supply planning. High level walkthrough on the results. Okay. Right. So we ran the S&OP algorithm, and then we system takes the demand at the Amazon, and then it pushes the demand into the network. And then we have seen the different outputs coming up at the DC to the customer on the transportation side, on the production side, on the capacity side, on the inventory side, etc. And then the algorithm we ran was heuristics, right? And then there is another thing called as most famous optimizer. Okay, and so there are heuristics, and then there are optimizer. I think you guys might have heard the terms of optimizer and the heuristics. So we're going to continue on the heuristics, and then we'll come to optimizer maybe 2 days from now on. Let's see how it goes. Again, on the heuristics, whenever we say heuristics, again in IBP there are two things. One is a finite heuristic, and then an infinite heuristic. Okay. First, where did we run it? So we went to the run here. We picked up S&OP operator, and then we picked up the heuristic, and then there are other selections like from what week till what week, what is a version that we are running on, base version, what is a scenario, it's a normal baseline scenario, and running by network. And then we picked up our network called Network India, and then we have run it. The name is time series based supply planning heuristic. Okay. And then, so where do we see that? We see that in a separate app called S&OP operator profile. So these are the profiles, just like the way forecasting has profiles, segmentation has profiles, inventory optimization has profiles, forecast error has profiles, snapshots has profiles, lag has profiles. S&OP operator also has a profiles. So these are the standard profiles that SAP gives. So as we know that whenever we copy the SAP IBP1 planning area, we will get the standard ones. All the profiles would come in automatically. Right? So now the profile that we ran was this. If you go inside, there are a lot of settings. So now so here in the heuristic type, see the infinite without shortages, that is called infinite heuristic. And then the other one is a finite heuristic. So it's a radio button that you need to kind of a select called as a heuristic type. And then it's either this or either this. We went with the infinite heuristic. Okay, what is infinite heuristic? How I mean how we say that it's an infinite heuristic? I think we talked about that on the other day. Let me write that down. Okay, what is infinite heuristic? In theory, infinite heuristic, what it tells is that supply chain can meet the supply chain is infinite. It can meet the infinite demand. It will not generate shortages in demand fulfillment. So it highlights, so it meets the demand, so it generates the plan which meets the demand. It will also highlight, it will also highlight the bottlenecks. Theoretically, yeah, did it make sense? You'll see it in the system, all of these points. Anything you want me to elaborate on? Or maybe let's first dive in and then we'll come back. Okay. So first thing, we saw this. Demand is 1,000 on the week 11. And then it used the capacity of 500 hours, which means the utilization is 500%. And then it's an alert. That's why it's coming in red in color. Alert highlighted. That means this is a bottleneck. So this demand cannot be met because on week 11, the demand is 1,000. And to produce that 1,000, we need 500 hours. The plant should run for 500 hours, not the plant. The resource W assembler in the Chennai plant has to run for 500 hours. And then the utilization would shoot up to 500%. This is alert. It just showcases, right? So now let me flip back. So how much it can meet? So the demand. Now we're going to play with the demands. Maybe I'll just. You guys are there with me? Stop me if you're not following anything.
Yes, Joshua.
Yeah. So I'm thinking of a better way to handle all of this so that you guys understand properly. Yeah, as it is getting recorded, let's just show. Let's go wide open. So now let me play with the demands. I'm maintaining the demands from backend. Ideally, the demands would come from the demand planning team. Supply planning team responsibility is, can we meet the demand or not? Right? The supply planning team, when the supply planning module is implemented, the users for supply planning, right? So their problem, their headache is that can we meet these demands or not? So demand planning team is telling all of this. Now, can we meet these demands or not? Right? So there is a thing saying. Or not marketing. Yeah. So you guys are saying this? Right. So the sales is from Mars, operations is from Venus. So they both are in two different worlds. So because the sales team, which is on the demand side, they're going to come up with the numbers, and the numbers looks unreasonable for the operational folks, because it is operational folks who have to procure, produce, ship, so that they can make the sale. So they both never meet, meaning they both fight all the time. That's a famous saying. Okay, so where are we now? So I'll come here. I'll make it reasonable, meaning that let's make the demand as a 90. 90 is very less, but let's stick to 90. Okay, you want me to take screenshots and put it in the PPT and write a point, or you're okay the things to get recorded?
If you can put that would be great actually. So yeah.
Naveen? Okay, anyway, I'll take that as a. Right, so how should we write it? The demands require the resource to run for 500 hours. Resource capacity is only 100 hours per week, but Infinite gives the below result, and the capacity utilization shows up results as 500% with MLR. Okay. This is, I'll say, use case one. Infinite results with overcapacity. If anyone asks what is infinite heuristic, this is the perfect answer we're going to tell, and then come on. Now we have to take all these scenarios and see how infinite behaves. That's when we compare, right? That apples to apple comparison we have to do. What's wrong? Something is really wrong. One second. I have this OCD. This is how you waste your time. Anyway, so let's put this here. Done. Now next say that use case 2, infinite results with material shortage. Right? I'll say with raw material shortage. And we'll see how that works. Okay, now the demands, how much are the demands? Demands are now 90, right? This is previous results. We need to run it, right? It's not a dynamic thing. You have to run the job to see the updated results. Running. Okay, now what happens? Now system would push the demands of 90. Now the DC has to supply 90. The production plant Chennai has to produce 90. And to produce 90, it needs an amount of memory chips, another amount of speakers. It's going to procure from the, it gives a plan that we have to procure this much from these vendors so that I can manufacture it. And when I manufactured it, there are these work centers and I'm going to require this much of capacity and blah, blah, blah. So let's have that first run and then we're going to complicate it. Complicated meaning our scenario of material shortage. Finished. So I'll quickly come here. What? Nothing happened. Nothing happened. Why? What did we do? What's wrong? Okay, I ran the forecast consumption. This is the top one. So it's better to go and run it from here. Just took one job from copy. Come on. Infinite run, step 2. Created by. Finished. Refresh. It's 90 now. Now go to the production. It produced 90.
Yes.
8001 material has a demand of 180 on Bose vendor Bose. So the dependent demand. 9001, which is our memory card. So on the Qualcomm, the demand is 270. Maybe we have said we need 3 chips, right? And then look at the capacity to make 90. It needed 45 hours. It is 45%. Right? So now everything is good. Now let's complicate. Let's add the description, layout, product ID, put ID description. Let me see. Okay. So let's play with the speakers. At the Chennai plant, the dependent demand is 180. Right? Projected stock is 0 because there is a demand of 180 and then it receives 180 from the vendor, and then that all that 180 will be supplied to the production process. That's why there is a key figure supply, and then you're going to end up with 0 stock. Now I'm just going to put here like this. So now I'm going to add the shortage scenario to the transportation. Okay, so now you see this 800 speakers, 8001 speaker, Chennai plant, Bose audio. There is a key figure called as the adjusted transport receipts. Okay, which means that you are adjusting your transport receipts. The key figure transport receipt says that you need to get 180. 180 has to be moved between Chennai and Bose. So now I'm going to say that you will need only so maybe 100. You're going to get only 100. Which means clearly we have put a restriction that you're going to get only 100. Like, why did we put 100? Maybe because the Bose team has told that, you know, we cannot supply whatever you want. We can only supply 100. So now you wanted to put that as a constraint in your planning so that you know that I'm going to get only 180 from my vendor. So this component, right? Now with this information, now let's see how the heuristic would behave. Infinite heuristic would behave. So ideally, what do we expect? We expect that as there is no stock from, as there won't be any stock, system cannot produce all that smartphones. It's finished. Now, if we go, first you see total customer receipts, that is still 90. That means whatever is a demand that is asked from, so system is going to supply all of the demand of, you know, that 90. So now if we go into the transportation, so now you see that system has given the transport receipts as 100. Okay, because you said your adjusted transport receipts is 100. For disconnect about. Now here the adjusted transport receipts of 100 resulted in the transport receipts. Now you also see that because of this, the demand that is going onto the vendor is also 100. So everything is adjusted. Everything is, kind of leveled up. Everything is leveled up. You know what? Forget about it. So let's just. Wanted to put that side by side so that it makes sense. So, now let's see. So now that means clear. So now its system is telling that, hey, boss, you just only give me 100 and you should procure only 100. Your transport receipts is 100. Right? This is looking good. We are good. Now let's go to the production and see what system has done here. Now see what system has done. System continued to produce 90. Galaxy Note 5. This is point number 1. What is point number 2? It continued to say the dependent demand is 180 in the Chennai plan for the speakers, because it didn't reduce the demand on the speakers. But on the Bose audio, the dependent demand came to 100. And now then if Bose is giving 100, but the Chennai needs 180, and all the 190 is being supplied for the production process because 90 has been produced. What happened to that 80? That shows up as projected stock as minus 80, which means that there is a material shortage. What material? Speakers 8001. In which location? Chennai plant. What is a shortage? 80. There is a negative. That means you are in short of minus 80. This is what Infinite does. So you ask this question that why system is doing all of this. System is doing all of this because Infinite will not have any shortages in the demand fulfillment. Nothing would stop in the fulfillment of the finished good, this smartphone Galaxy Note 5. It will highlight the bottleneck. So this is a bottleneck called as a projected stock minus 80. Okay, so which is this point. You guys understood? Hello.
Yes, Joshua. Hello. Joshua, can you hear me?
Yes, yes, I can hear you.
Okay.
You guys understood, Nabi, Naveen?
Yes, 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 yes.
Hello. Naveen.
Yes, Joshua. I think you are not
Yes,
able
yes,
to
sir.
listen us.
I cannot hear you guys. What happened?
Yeah, we can hear you.
Hello. Can you guys speak up now? Nabi?
Yes, we can hear you.
Yeah, now I hear you. Okay.
Okay.
You guys followed what I was telling?
Yes. So I think we were saying yes. You couldn't hear. Yes.
Yeah, okay. Someone dropped off?
No, no.
No. Okay.
No,
Now
no.
the question. Yeah. Now the question that first of all, is this realistic for some companies? Yes. Why? Because they want to meet the demand by hook or crook. To meet the demand by hook or crook, where all my pain points would come in. So where I will, have issues with my material availability, with my capacities shooting up, with my transportation taking hits, etc., etc. So then they wanted to see all these pit holes, all these bottlenecks, all these problematic areas, and then they will go and then they will fix it. Okay, which means that the moment the moment if I go with the finite heuristic, what it would tell is that at the Chennai plant, now Chennai plant, the dependent demand, the finite heuristic would show as 100. So with that, what happens is that you will never have a visibility of what was truly needed, how much of the speakers I truly need. So that part you will never know with the finite heuristic. The infinite heuristic only will give that information. Just give me a minute. Right. So yeah, that is what the infinite does, and the use cases for the infinite heuristic. And mm, right, and also sometimes the you know so there are some companies, right, where in here the 500% utilization is showing up here. So in this case, some companies, you guys are there with me? I'm back.
Yes, yes.
Yes.
Yeah. So in some companies, what happens is that, okay, if the demand is 1,000, I'm going to have a utilization of 500% because I need 500 hours to make. So they're ready to scale up. Some companies are ready to scale up. And then, or some companies might get it from another co-packer from a different production location. So they don't want to limit their whole plan just purely based on the initial capacities that they have, the standard capacities that they have. The standard capacity is the plant is available 100 hours a week, but they don't want to limit themselves, right? So that is when the infinite heuristic would come in. Okay. So one more thing, I'll tell another use case. So I'm sorry, guys, I should be writing it all of it, but as it is getting recorded, quickly make a note. Right. So one more point. The first point that, as I was telling yesterday, that there are like 60 to 70 outputs that comes in as part of a supply planning solve. So companies, when they implement supply planning, they are not interested in all of this. They're interested in only specific outputs and specific part of the supply chain. So there are companies where they're interested only on the production side. They don't care how much is being transported. They don't care how much has to be shipped, etc. So what they care is on the production side, what is happening in my plant, what is happening. Correct. Uh, so that could be their problem area. Or some people, they just only care about their procurement side. That how much of raw materials I do I need. So if this is the demand, this is my network, these are my DCs and warehouses, then how much of the procurement I need. So all they care is those outputs, and the other outputs would be there, but they don't mind, wasting their time in looking into that. I mean, they won't do that. So all they care is open up the procurement side, and then that data they'll integrate to the S4 as a purchase requisitions or whatever. And they're going to take the first 6 months of the IBP data and use that key figure data, and they use the baddies and BAPIs to create a purchase requisition. Because IBP as a planning tool has told that you have to procure these many memory chips, these many speakers from these vendors. So if that is a case, right, in the other case where they only care about the production side, so they really want to see how much of the raw materials I need. So I don't want to be restricted by the other constraints in the supply chain network. So they just say that, okay, give me a pure bomb explosion. That if the Galaxy Note 5 needs 1,000, tell me that I'm going to need 2,000 speakers. That's all, plain and simple. Don't restrict it based on the capacities or etc. etc. Okay, you also understood this point?
Yes.
Great. Now let's run infinite. Let's run finite on this and see the trick, right? So now, if you guys have carefully followed in the 1,000 example, you should ask a question that, hey, is it stupid enough that system is giving this sort of results? Yeah, we'll see that. So it's running. Yeah, let it run. We'll go step by step. There's no hurry. So I'm putting up the 1,000 back again. Then I'm running the infinite. I want to cover as many scenarios as possible, guys. So, I mean, if we start writing, it might take some time, but just put in here. Add 1,000 as a demand, right? So now the capacities could show up to 500%, and there is an alert, right? So there is this adjusted also. We need to take it off because we no longer need this. Okay, now here, now don't you see something is off in this output? Hello.
Yeah, yes, Joshua.
Yeah, what is off in here?
So your utilization is more.
Okay. Yeah, that is, yeah,
The
it is, yeah, that's the first one. Anything else?
number of products planned by resource is less.
Oh yeah, but there's only one because the master data we made only note 5 because to keep things simple. What is off for me is that, okay, there is a demand of 1,000, agree on week 11, and then yeah, you produced all 1,000. Yes, you follow the demand. I understand that's a infinite. You are programmed to do that. Fine. Utilization shoot up to 500%. Okay, because the capacity you require is 500 hours, and you have 100 hours only. The math tells that it is 500%. Fine. You are shooting up.
Right. Your production is more.
Now my point is that from a common sense perspective, what ticks me off is that what are you doing on week 8, 9, 10?
Yeah.
You're doing nothing.
Working.
Why can't you produce more in week 8, 9, 10?
Avoid
And
this.
Yeah, avoid. I mean, try to avoid that 500%. Why can't you bring that down? That's my, so that's what some companies would ask. What are we talking here? We are talking a concept called as very famous concept called as a very famous concept, and PPD has also done that. So it's a concept of how you level your capacity. PP also it's a crazy topic. Is a process that balances supply and demand in the production system, right? So that anyway, let's stop. Now let's create finite heuristic, and the finite heuristic does that very well. I'm going to say click on create. What type of algorithm you are creating? Heuristic. Okay. Now you need to maintain the values 10101. Name is finite heuristic. Description is finite heuristic. Planning area is Jan train. Then here finite heuristic I'll choose. I'll click on save. And now we just created a new profile called fine. There are a lot of other settings. We'll go them one by one, but for now, finite heuristic, right? So now go back here, copy this. Now I'm saying yeah. So even with the finite heuristic, what happens is, let's see what happens with the finite heuristic. Okay, first, by definition, what is finite heuristic? What does it do? Works as in supply chain is infinite. This works as in supply chain is finite. It can meet the demand as per the supply, as per the possible supply, as per the available supply, I would say. Okay. If the supply is only 50, I meet only 50. I will not meet all the 1,000 or 10,000 or 1 million or your infinite demands. It will generate shortages in demand fulfillment. Okay. And then it would not highlight any bottlenecks. Finite heuristic is more reliable plan. Not reliable plan, realistic plan. Finished. Let's go. First, go to the customer demand. Now you will see a different number showing up for. See the customer receipts 800. Okay, the demand is 1,000, but it met only 800. So that means Amazon will not get all 1,000. With the capacity balancing. Amazon demands of 1,000. Out of the Amazon demands of 1,000, only 800 can be met. Receipts will be only 800, right? Now, if you open up all the supply planning results, now you will see that everything was, limited to the available supply, right? Now I'll go to let me go to the production. Now let's see what happens in the production. Now you will see the leveling. So you see now the production is 200, 200, 200, 200. Yeah, it might be overwhelming, but just, I need to go key figure by key figure to understand all of this. So first, the demand at Delhi, the dependent demand is 800, right? Dependent demand, not dependent demand, dependent on the network. Demand is on when demand is on week 11. This is the first point. Okay. Now the dependent demand at the Chennai plant is also on week 11. Point number 2. Now to meet the 800 demand, system finite heuristic has come up with the plan where it started producing from week 8 itself. Week 8 it produced 200, and that's the 200 is put up here, and then it produced another 200 on week 9. Plus you produce another 200, then the projected stock becomes 400. And then week 10 you produce another 200. So now you have 400 of the stock. That plus 200 becomes 600. And then you produced another 200 on week 11, right? So that 600 plus 200 becomes 800, and that 800 is supplied. The projected stock becomes 0 here. Now, if you ask a question, hey, why 200? Because you can only produce 200 with that capacity. Now, if you go to the capacity tab, you will see that 100%, 100%, 100%. That means if you run 100% of your capacity, you can only produce 100, because that's how we maintain the capacity consumption rates and etc. in the master data. You just followed this. Tell me, I'll stop here. You have to understand this. Otherwise, there's no point of going forward. These are all basic scenarios we should understand. So yeah, this takes time. The supply planners are quite seasoned with all of it. So the moment they say it, they'll quickly understand. In fact, before even running, they will tell this is how the output should be. This is how I want my plant to come up with. If there is a high demand on week 11, and then I need to kind of produce in before, so that I'll catch up to the demand on week 11, the high surge. Right, but that also happens the same, right? So for example, even if we have like, let's say we set up a kitchen, and then let's say we are making chocolates, something we are in the OT, and then we make chocolates, and then there is a demand on week 11 that we have to send this much of stock to, let's say, Hyderabad, and they are asking for 1,000. And but in the factory that we have in the OT, when we can only make 200 chocolates a day, right? Because that's the capacity we have. We have a building, and the building has, like, we have 20 people, and we have these, whatever, the freezers and the ovens and baking machines, etc. And at maximum you can make 200. You cannot make more than that. And now if someone calls you and tells you that, hey, by week 11 you need to send me 1,000, and then what you will do, you will come back, and then you will see that, hey, how much I can do. You are already in week 8, and then you think that, okay, I can do 200, 200, 200, and then I can make 800 by that week 11, and then I can ship only 800. This is how you do, right? In the supply planning, and that's how it does. Okay, and you understood the concepts of projected stock. Also, projected stock is that the stock that you are projecting. It's not realistic. It's in the future. This is all planned.
Yes.
Yeah, Naveen?
Yes.
Yeah, so in the infinite case, we saw different results. Now, with the finite, you just saw that, as I was telling, more realistic, data than And now if we go to the capacity, I'll also
So
take this screenshot.
any cancellations or order changes that will allocate to the different customer immediately, or
We need to rerun. We need to rerun.
okay.
Need to rerun that job. I need to rerun more.
And that
Again,
takes this
don't go
form.
in. Yeah, don't go into the concept of orders, right? You're
Okay.
getting into another realm called order-based planning. We are
Okay.
still talking about key figures. This is just still a consensus demand that
Just the
you
plan.
remember, there are
That's
no orders. It's just a forecast. And with the
okay.
forecast, we are kind of,
Paying
correct. Yeah. I mean, a lot of
essentially.
companies does that. So the what you are telling is a real-time execution. That there is a real sales order from Amazon, and then
Yeah,
how the entire
actually,
scheduling have. That's a
I just
yeah. So
literally went with the examples. I was asking. Okay.
yeah, correct. Yeah, I understood. So initially, when I introduced into this, like I was like, what is all of this? All these numbers and the reality is different, right? And then it took me some time to appreciate the planning side of the things. I was more into the real world operational this thing, and yeah, then it took me some time to understand. Oh no, there is this concept of planning also. You do the planning, right? And then yeah, all that preventive, whatever, all that stuff. So yeah, so like I mean, take the same. Like let's say we set up that company called Chocolate Factory, and then we are making chocolates. And then let's say we are making orange based chocolates and cranberry based chocolates, etc. And then you can't just sit and wait for the order to come in and then immediately you'll become into war mode, and then you start scheduling as per the phone calls that you receive, the sales orders that gets placed from Hyderabad, Chennai, and etc. Right? That's a stupidity. You need to be first ready, and you need to at least have a planning for next 4 or 5 months. So if you have a proper factory and if you're making proper chocolates, and then we will have one person who will give us the demands, and who that guy will tell that, okay, we're going to have this orange flavored coffees, chocolates, this is going to be the demand. Hyderabad might ask this much, Chennai might ask this much, Kerala might ask this much, our distributors, wholesalers, whoever are placing these orders. And then maybe in our website, online e-commerce, we might see a demand of 1,000. So this is overall demand. And to make this orange flavored chocolate, okay, we need all these herbs, these flavors, etc. And then you need we have to do this sort of a planning. And then sometimes definitely where things get complicated is that here we're talking about only one product. All the products like occupying this assembler, right? In this example that I was telling, is let's say you're making orange, cranberry, vanilla, and then classic, four different chocolates. Let's say you can make only 200 in this example. Now assume the demands were 200, 200, 200, 200 for all four flavors. Now what are you going to do? Now how are you going to do? You have to make 800, but you can only make 200. There's a vanilla, there's an orange, there is cranberry, and there is this thing. What are you going to do? That's why you need planning. And then you're going to sit and decide, should I make 50, 50, 50, 50, and then at least every product is made, or I just launched the cranberry flavor, people are asking for it. Maybe I should strategically, tactically, I need to continue this cranberry. The moment I stop producing cranberry and the moment I start shipping cranberry to the people, that they might never come back to the cranberry. I wanted to strategically, I want to continue with the cranberry because I have set up a farm where I'm procuring and making cranberries on my own, with a decision that I'm going to make more of a cranberry based chocolates. So that means I'm going to come into the IBP, and then I'm going to say that I'm going to sacrifice the other flavors, and I'm going to continue to produce 90% of my capacity will be dedicated to the cranberry flavored chocolates. And the rest 10% I'll produce my classic vanilla chocolate because that is my bread and butter. That is my this. You guys are understanding what I'm saying?
Yes.
Yeah. I'm also telling about the importance of planning. I mean, we can't just run with the orders. We can't just wait for the order to come in. Okay, the Amazon has placed these many, and then the Hyderabad distributor, he called and he is like, yeah, he asked for this, and then what should I do? No, you're reacting very, very late. And what's the point of planning there? So you need to have some plan before of how much I'm producing, how much I should procure this cranberry flavor, whatever, from my vendor, who's where I'm getting it from, let's say Dubai, or some supplier sitting in Mumbai who's giving us all those whatever raw material that goes inside these chocolates. We'll stop here. So Naveen, I hope you're following.
Yes.
Yeah. So okay, finite planning. Let's continue on the scenarios, right? So, yeah, we just saw the capacity leveling in the finite heuristic. So maybe I think I need to write this down. Let me write this down. This is very important. In the above capacity utilization, we see a leveled plan where system proactively, right, or intelligently started producing from week 8, even though the demand is on week 11. System continued to run in full capacity and produced a total of 800. Capacity utilization will never will will never cross the 100%. Right? That is the key. When we say finite heuristic, for the what people would like to hear is that it respects the production capacity like anything. So it will only do how much, whatever is the capacity maintained, in the plant. Right now, let's go back to our previous example of the material shortage one. Right. So now let me go to the demands. Now I say. Is it two? Is it 100? Is it 100? 200, 200, 200, right? Save. Running finite heuristic again. Now I maintained 200, 200 as a demand. Then system would give 100%, 100%, 100% everywhere. And then we'll also see the demands on the components. Then I'm going to go to the components and I'll put adjusted again, and we'll see what happens. Adjusted or everywhere, adjusted or on the transportation side, on the customer side, on the production side, like everywhere. So in example, I'm showing only on the transportation. You can put it adjusted anywhere. Adjusted means that the planner is adjusting, that apart from the system generated outputs, I am adjusting and I'm telling that this is what is going to happen. In the previous example, that there are competing demands for cranberry, for vanilla, for orange, and if you decide to go with the cranberry as a priority and then vanilla, you're going to go and make the orange colored coffee as a zero. Adjusted production receipts is zero. That with that, orange flavor will never be produced. Orange will never be produced, and the bill of material of orange will never be exploded, which means all the components that are needed to make that orange coffee, you will never see demand on those components. And you will never see demands against the vendor of those components. Right? That's how people, they adjust it is like a lever. It's like, you on and off, you turn it, you switch it off, then you open it, all that. You guys know the lever, right? So the lever where in the machines. Why it is taking so much time? Crazy. Yeah. So now if I just go to the production, refresh. Okay, so now you see that the thing that I'm highlighting is speakers is 400, 400, 400, 400 across. So now if I go, right, instead of 400, I would say that you're going to get only 300. Now what happens? Can anybody tell? Now I'm running finite heuristic. With finite heuristic, what happens? Let it finish. We'll see. Actually, why it is taking so much time? We are running it for next 2 years. That is the problem. You see, it is running till 2027. There's absolutely no data till 2027. We have only one bucket of data. Unnecessarily, we are putting strain on the system. So anyway, so now if I click on the refresh, now you'll see that, oh, intelligent. Okay. It increased the demand here. You see, it procured more on week 10. Yeah, which is fine. So now, which is good. That's why infinite heuristic is, sorry, that is why finite heuristic is much better. It has some sense. So what happened that ideally the demand is see the dependent demand is 400 on the speakers in the Chennai plant. But there is a restriction, right? You can only get 300 on week 11 from that supplier. So what it has done, it has increased the demand of 500 on week 10. So which means that the 100 that is missing is added on to week 10. So it procured more on week 10. And then that remaining 100 was kept as a projected stock. So this 100 is added into the next week. So that you receive 300 plus the excess of the 100 from the last week, 400, total 400 is applied. So So the finished good can be made and the demands can be met. But this is the finite heuristic result. So now ultimately, like let me put something here. So this is 1 and this is 2 and then this is important. At the Bose dependent demand, you see this is 500 and this is 300, which means that the restriction that you have put, which leaded to a shortage of 100, was passed on to week 10, and the demands have automatically increased to 500. I hope you guys are following. So this is a thing with the supply planning. So they say that understanding the results would take time. So you just run it, and then now you want to understand like what exactly happened now. So you have to put some time, and then this is what supply planners does. And then they run it, and then they look, they just like they just look at the screen and then try to understand like what has happened, what system has proposed, etc. These are all simple examples. Imagine the same thing happening for like 200 components and multiple finished goods and the complicated supply results that comes in. On week 11, $400 speakers are needed, but there is an adjustment made with 300. This will make the finite to come up with the transport plan of only 300 on week 11 to respect the adjustment. Correct. This is the premise. Now let's write down what has happened. So now this is at the plant. I'll put 1. Dependent demand is 400 on week 11. This has come in purely based on bomb explosion from the finished good. What is that? Galaxy Note 5 and the component speakers required as two each. Now the second point. Finite heuristic did not restrict the production of Note 5 as per the shortage of beacons, but instead it pushed that shortage onto the previous bucket and increased its demand at the Chennai plant, making the system to procure more from vendor and keep the excess stock in week 10 so that it can catch up for the demand on week 11. Guys, I'm sorry if my English is not that correct, or if it is repetitive, or if it is not to the point. At the vendor,
You are good, no worries. Yeah.
yeah, thanks. At the vendor, what happened was Bose will automatically see a slight surge on the demand at week 10, and also respecting on the demand on week 10 to 500, and also respecting the adjustment of 300 on week 10. This is what the final does. Okay. I want to stop here before getting into the other scenarios, because that will even further complicate. So you guys are getting a hang of it, right? The finite, infinite.
Yeah, trying to.
Yes.
Yeah.
Yeah, kind of.
Yeah, kind of. Oh, guys, I mean, why you're saying kind of, even after this all elaboration, but
No, no, we need-
conceptually you guys understood, right?
Yeah, yeah. Correct,
Conceptually you understood. Yeah.
No,
So
we
at
need to
least
read-
theoretically, yeah, theoretically you can explain, but recreating the whole thing, yeah,
Yeah.
I do understand that you guys have to get into the system, spend some time. Maybe it might not come the results properly. Yeah, there are multiple things that you are seeing. I'm getting into multiple tabs, opening different key figures. But conceptually, like what is happening, etc. So yeah, like so. Just wanted to go through the key figure
It
names. Was there
is
any key figure names?
in DP. It is more.
Sorry.
It is definitely not like a demand planning. This one is more
Yeah,
of
yeah.
it. So it's a
Man,
kind of
you just
fun,
we're just
fun
starting the
environment.
yeah, we're just scratching the surface of the supply planning. So there are, you see all these different settings. So it's going to be, yeah, a lot of stuff. I mean, if I go to the optimizer, then it becomes even more murky, right? So optimizer is cost driven. So till now, I think you should ask the fundamental question that, hey, you're saying heuristic and optimizer, what is heuristic or optimizer? So heuristic is a rule based program where there are certain rules, and based on that rules system would function, whereas optimizer is based on cost based. So system would yeah, when we go to the optimizer we'll talk there, so I don't want to confuse you guys, but for now, finite, infinite, we have very simple network. So tomorrow we're going to complicate our network, which means that we're going to add multiple customers. Amazon, maybe not multiple, we'll just stick to two, Amazon and Walmart, and let's put demands for both and then see how system would respect which demands I need to respect. Amazon is important or Walmart is important.
Okay.
And then let's say we have two plants. We have only one plant, Chennai plant. Let's add another plant in Hyderabad. And then let's see how demands will be pushed to both the plant, right? So you can produce in Hyderabad and also in Chennai. So how to have a control on the network so that you will tell that which plant has to produce what, etc. Like, I mean to say, both the plants can produce all the products. It's not that Hyderabad can only produce this and etc. Then it is nice and easy again. So there is no complication. It's like smartwatches are made in Hyderabad, smartphones are made in Chennai, nice and easy. The complication comes in when both the plants produce both the smartwatch and the phones. Then how system would distribute these demands, across these plants and meet the final demands.
Mhm.
Okay, I'll stop here, guys. Well, I think tomorrow we're not catching up, right? Tomorrow being Saturday, and I think, yeah, Monday again.
Yes.
Yeah, so it's going
Sorry,
on and
Joshua.
on, right? This is the biggest batch that I have, worked in, and then I've intentionally come up with this elaborate plan. Otherwise, I won't cover these many. But by this time, the entire sessions would be completed, but I'm just pushing myself so that you guys understand it completely. So normally nobody covers in this great depth of detail in any of the study. I hope you guys are catching that. So yeah.
Yeah. Yes.
Okay. Thanks, guys. We'll catch up on Monday.
Thank
Bye.
you.
Thank you.